Alright, okay, let's look at these examples here. So you can refer to your notes. That's asking you to find the probability of by using these tables of outcomes here, or we say it's contingency table, where we have obese, normal, underweight as our variable, and tall, medium, and short as our variables. So the following tables relates the weight and height of a group of individuals participating in an observational study. So this is actually a contingency table, or we say table of outcomes, because we can get the data. For example, we want to know that how many individual, right, that having obese and tall, which is 18%, right? We have 18% which is tall and obese, right? If we want to know how many total of normal, right, means that the weight is normal. Very easy, right? We want to know total of number of individual which have a weight with normal weight. Means that we total up these three, right? 20 plus 51 plus 28, then we will get the number of individual which is have normal weight, right? If we want to know number of people which have tall, right, in the for the observational study, will be I add up these three, then I will get the number of individual which is tall, right? The total number of tall individual will be for this, we total up these three, right? So if we want to know who is tall, short and underweight, the height is short, consider short, and underweight, which will be 9, right? Short and underweight is 9. But before this, we have to complete the contingency table by total up all the values here. Alright, let's total up. You want to find the numbers of obese, either they are tall, medium, or short. We total up this. This is the number of obese individual, right? So we total up these three. Okay, let's total up everything here. We will total up these three, we get the total of obese. We total up these three, we get the number of individual which have normal weight, normal height, right? So for normal, the weight is normal, right? So we total up these three, we have the underweight, right? The total number of person which have underweight. So we total up these three, we have get the total of the number of people, of individual participating in this observational study here. Alright, let's complete the table. Alright, okay, I have complete total up the values here. So I have complete total up these three to getting this value. Total up, this will be the medium height, right? The height will be medium. So this is total number of individual with medium height, right? So all you total up, you get 205, and this also you were getting 205. So, okay, we have complete the table of outcomes. So now let's answer the how to using this table of outcome of contingency table in helping us finding the probability. So find the probability that a randomly chosen right, one person, a individual from this group is tall, right? Is tall. So means that the probability here, the probability for this case here, that the person is tall. Alright, I usually will giving them some alphabet to represent tall, medium, short, right? Obese, normal, and underweight. Alright, obese, normal, and underweight. So I label it first before I answer. So now we want to find the probability that the individual is tall, right? Oh, very simple. So, okay, I'm going to write in this way. So probability that the individual is tall, right? Is tall. It will be, means that how many of them is tall, right? Either they are obese, normal, or underweight, doesn't matter. We just want to know they are tall. So it's 50 of them, right? 50 of them out of 205. Alright, out of the total is 205. Means that out of this total, 50 of them are actually in the height of a category of considered as tall. Right? So we have 50 over 205, which can be simplified to become 10 over with 41. Alright? 10 over with 41. This is a probability that a randomly chosen individual from this group is tall. Alright? Alright, okay, let's look at part B. Find the probability that a randomly chosen individual from this group is underweight. Right? Underweight. So it means that its probability of underweight is represented by U, right? Probability of underweight. So how many are underweight, right? So we're looking here, right? As this total up, either they are underweight and tall, underweight and medium, or underweight and short, right? So total of these three will be 46. 46 out of total 205. So this will be your probability of underweight. Alright, this is the probability of underweight. Alright, let's see more examples from this question. Alright, let's look at part C. Find the probability that a randomly chosen individual from this group is obese and tall. Right? We also can get the information of number of individual which is obese and tall. And usually we refer to intersection. So obese intersect with tall, right? Obese and tall. So obese and tall is 18, right? 18 of them. So mean it's 18 out of 205. So this will be your answer. Alright? Very simple. So means that you see that from here, obese and tall, this will be 18 of them, right? 18 of them. 18 out of 205. Alright? Again, I repeat again. Find the probability that a randomly chosen individual from this group is normal weight and medium height. Right? Normal weight and the word, they use the word and, right? Normal weight. Normal weight. I label it as N. And medium height. Right? And medium height. So, normal weight and medium height. So, total of that from the, this is actually data, right? This table displaying the data. You can see that normal and medium. How many of them? 51 of them, right? So 51 out of the total is 205. And this will be your answer. Very simple, right? Okay, let's look at part E. So I will give various types of question that you need to know, right? Alright, how about this? Find the probability that a randomly chosen individual from this group is underweight or short, right? They use the word or. Underweight or short here means that if you look at here, underweight, underweight, we have three of these, right? Underweight, 12, 25, 9, right? So this is all the category of underweight. Or short, right? Or short. So means that even though it's not underweight, it's either obese or normal, but in the category of short, we are still accepted, right? We are still accepted. So it means that underweight or short, either they are underweight or they are short, even though they are not underweight but they are short. So this is the meaning of or, right? So we add up all this, right? We add up all this here. So it's your probability of underweight or union, right? Union or short, right? Underweight or short. So it means that we're adding up 12 plus with 25, 12 plus with 25, plus with 9, plus with 28, plus with 14, divide by 205, right? The meanings of or and n is very different. So if let's say, if the question asking for n, right? So underweight and short, underweight and short, this will be 9, because the word n here tells us that the person must be underweight and at the same time the person must be a short, the height is short, right? So underweight and short, so it will be 9 of them only, will be only 9 of them, right? But when they use the word or, it's a big difference, alright? When they use or here means that or means either one, either they are underweight, we choose, or if they are short, we also choose. Okay, so short, okay, short but it's obese, never mind, as long as you are short, we are choosing you, because underweight or short. That's the meaning here, all right? We're just adding up 14, 28, and all of this is underweight, right? So we add up these 3 plus these 2, divide by the total. Then we will get the probability of underweight or short, right? Which give you 88 of them, right? 88 of them out of 205, right? So this is a probability. So let's look for more example. Okay, now we are going for the more important part of this question will be the conditional probability, right? How to read conditional probability from the contingency table. All right, let's see. All right, okay, let's look at this question. You should listen to this, what I'm teaching in this question. It's very important to know how to answer this question. So you see that find the probability that the randomly chosen individual from this group is tall. Tall, given that, there is a keyword here, right? Given that it's a conditional probability. Conditional means they give you a specified region, right? Total, given that. So the individual is obese, right? Tall, given that the individual is obese. So means that the probability that the person is tall, given that the person is also obese, right? Tall, given that the individual is obese. So now, we no longer divide by 205. This is the most important thing here that you must know when you have a contingency table. So you must know how to read. So because we know that given that we already tell you that the person is an obese, right? Is an obese individual. So means that from the obese individual, right, from this row here, the total number of obese individual will be 60 of them. So we will divide by 60 rather than divide by 205 when we calculating conditional probability. Because why? We know it's come from the obese individual, because it's given that individual is obese, right? From this obese individual, right? From this obese individual, we have short, height, medium height, and tall, right? But they said probability of tall given obese. So means that from these 3, we just take from these 3 values here, because from this 60, right? From this 60, given that from the obese, right? Which is tall? 18, right? 18. So means it's 18 over with 60. Alright? So which will give us 3 over 10. It's 3 out of 10. Alright? So this is the way different. It's very different from finding other probability. This is a conditional probability, because they said given that we know the total now is come from the obese, right? 60 of them. So from this obese, the one that tall is only 18 of them. 18 divided by 60. Alright? So let's see another example. Alright, okay, let's look at this question. Sorry, this is part G. So find the probability that a random chosen individual from this group is underweight. Underweight is underweight. If they just said is underweight, if the question just said is underweight, then it will be 46 out of 205, right? But they said given that, that's the conditional probability. Means there is a condition, right? There's a condition. Given that the individual is short, right? Given that the individual is short, so means that it will be underweight given that the person is short. So means that the total no longer 205 here, because we have already know that it's come from, given that we have already tell you that the individual is short, right? So means that from the category of short here, you have 14, 28, 9, total out of this you have 51. So we should divide by 51, right? Because we know it's given that the individual is short. Means that comes from the short, right? From 51, from the 51, how many of it is underweight, right? You have 14 obese, right? From the short category, short individual, from the short individual. So, sorry, for the individual which is short, so it's 51. So from these 3, they may be obese, normal, or underweight, right? So it's underweight given is short is from 51, 9 of them, right? 9 of them is underweight. So this is the way we should answer the question. Very simple, right? Which will give you 3 over 17. So very simple. It's actually I just want to I want to tell you how to read the probability from the contingency table. That's the most important, how you want to read a conditional probability, intersection from the contingency table, and the probability of an event from this contingency table. Alright? Alright, okay, let's look at this final question. Are the events obese and tall independent? Okay, very simple. Before that, I have to review back what is meant by independent. For example, events A and B are independent. If events A and B are independent, right? If events A and B are independent, alright, I have to write the word if, right? If events A and B are independent, right, then we say that the probability of A given B is equals to probability of A, right? Or we can say that probability of B given A is probability of B. If we can verify that either one of these, alright, or you want to verify both, alright, verify both. So if probability of A given B is the same as the probability of A, then we say that the events A and B are independent, right? Independence, or this is the first method, right? A second method, we're using the multiplication rules, alright? So if they are independent, so probability of A intersect with B will be equals to the product of probability of A multiplied with the probability of B. Very simple. Alright, if you're able, either one of these is okay. Alright, if you're able to prove that the probability of A intersect with B, the probability that you get the value is the same as the probability of the A individual, respective individual, you multiply, the value will be the same, then it will be also show that the two events are independent, right? So for this case, I'm going to show you two methods. Alright, you have to know two ways of showing this. Alright, let's see. Alright, okay, let's see how I want to determine whether the whether I want to determine whether the events of obese and tall are independent. Alright, we just determine. Alright, so here we have labeled this as O and this is as tall, right? Tall. So easy for me to write. So means that we can verify by this using the method 1 just now that I mentioned, alright? Because it's between event A and B, now it's O and T, right? So you can show that O given T, right? O given T, the probability of O given T. So what is the probability of O given T, right? Probability of O given, right? Given from the tall category, right? From the tall, we have 50 of them, right? 50 of them. So it means that it's not 205, but it's 50, right? Because we know it's come from the groups of tall individual, right? Of the tall individual. So 50. So out of these three, right, is have obese, normal, and underweight, right? From here, we don't look at other part of this because we already know that given that, the meaning given that means that we know it's come from the tall here, so we no longer view other side. So we know that which is obese, right? 18 over with 50, right? Later on, we try to find the probability of obese. Probability of obese will be total 60, right? 60 out of 205. If we able to prove that these two values are the same, just now I have told you that if the probability of A given B is the same as the probability of A, if these two values are the same, then we say that events A and B are independent, right? So is obese, the events of obese and tall, O and T are independent or not? So will depend on if these two values are the same or not, right? You can try to simplify. So from the calculation here, you already know that, right? The probability of O given T is not the same as the probability of obese, right? They are not the same. So if A and B are independent, the condition here will be, it must be equal to the probability of A itself, right? So, but they are not equal. This is 9 over 25. This is 12 over 41. So what can I conclude? So we can say that the events orbis, okay, I don't write, so I just tell you the events orbis and tall are not independent. All right, the events O and orbis and tall are not independent. All right, are not independent, or in short are dependent, right? They are depend to each other. All right, means that so orbis can be depend on the category of tall, and tall also can depend on the orbis, the category. All right, because all right, okay, let's see how to using a second method to verify that the two events are independent or not independent, right? So you have already used the first method, you know that by using this, you know that it's not independent, right? So let's see. So you have two ways of doing this, all right? All right, look at the second way of showing that, okay, to determine whether the events of orbis and tall independent, so whether they are independent. So the second way will be you find using this, right? The probability of if events A and B are independent, we say that the probability of A intersect B will be same as PA multiply PB, right? So if let's say the probability of A intersect B is not the same as probability of A multiplied probability of B, then they are not independent. Okay. So now we're going to find the probability of orbis intersect with tall, right? Orbis and tall. So orbis and tall, we have 18 of them, right? 18 out of 205, right? So we know that the probability of orbis will be, orbis is 60 of them, right? 60 out of 205, right? So and we have the probability of individual which is tall. Tall is, we have 50, right? We have 50 over 205, right? So 50 over 205, and probability of orbis will be 60 over 205. So we try to multiply these two, right? We try to multiply these two, probability of orbis multiplied with probability of tall, right? Means that we're taking 60 over 205 multiply with 50 over 205. So then we calculate, see whether the values after multiply is the same as the probability of orbis intersect with tall. Right? Again, I have calculated is 120 over 1681 after simplify, and these two values are not the same, right? So then we can already explain that, right? Since the probability of orbis intersect with T is not the same, right, as the probability of O multiplied with the probability of tall individual which is tall, so they are not the same, right? So therefore the events orbis and tall are not independent, right? Now the same statement as just now, and not independent, or they are dependent, right? The events orbis and tall are depend to each other, right? So this is already verified. It's already determined. These two events are not independent, right? Are not independent. So I hope you understand. I just using a very normal explanation to tell you how to use the contingency table. Alright, that's all for this video.